Hello everybody and welcome to this lesson. In this lesson we are going to talk about the filter primitives Blur and Convolve. Blur is quite easy and straightforward, while Convolve is a bit more difficult to explain, but if you try your best to understand it, then I promise I will try my best to explain it. So let's start with Blur. Blur is very straightforward. I'm going to draw a circle and I'm going to add a new filter and I'm going to add Gaussian Blur effect to it. And here I have two inputs, the blur in the X direction and the blur in the Y direction. If I apply the filter, I see that the effect is in fact exactly the same as if I were to add a blur using the fill and stroke dialog. The only difference is that if I want, I can uncouple the blur in the X direction and give a bigger blur in the X direction than in the Y direction, or vice versa. Now, in fact, blur is a particular kind of convolution function. What is a convolution function? That's what I'm going to explain now. First of all, let's have a look at what the primitive looks like. I'm going to go to Add Effect and I'm going to add the effect Convolve Matrix, and I'm going to click on Add Effect and I will have a look at the parameters. Here we see that we've got a size that shows the size of this matrix here. A kernel, the kernel is just a matrix. A matrix is a series of numbers with a number of rows and a number of columns. Here we have 3 rows and 3 columns. We also have a target, but I won't talk about that for now. Also a divisor that will come up later, and the bias will also come up later, and edge mode, I will also talk about that later. For now it's enough to know that we have a series of numbers in a number of rows and a number of columns. This is called a matrix. I can change the number of rows and the number of columns by changing the size. So now let's talk about what these matrices actually do. Here I've drawn 2 matrices, the M matrix and the P matrix. The M matrix corresponds to the input values here, and the P matrix corresponds to the picture. Each P is 1 pixel, and each P has a red value, a green value, a blue value, and an alpha value. And what you do is you recalculate this picture. For each pixel you recalculate the red value, you recalculate the blue value, etc. using this matrix. So what I do is, when I want to recalculate P11, I move my matrix here and I multiply each value of M with each value of P and then add them all together. So I multiply by P11 multiplied by M22 plus P12 multiplied by M123 plus P21 multiplied by M32 plus P22 multiplied by M33. Then if I want to recalculate the pixel P12, I move my matrix like so, and I multiply all the overlapping elements and add them together, and I continue doing that for each pixel and each color of each pixel. For example, for P44, I would place my matrix like this and multiply P33 with M11, P34 with M12, etc., and then add them all together, and that would be my new value. So that's how it works. If you didn't quite understand it, it's not that important. The main thing is that you know how to use it and that you know some of the most used examples and what they do, and that's what we are going to learn next. So here we have some examples. The first example is not really used in practice, but it is useful to help us to understand how the convolution matrix works. Let's select our image and let's have a look at the matrix. The pixel itself in the middle is multiplied by 1 and all the neighboring pixels are multiplied by 0, and we add them up. So in other words, only the pixel itself counts, and we result in a picture which is exactly the same as what we had before. Then we've got blur. This is a block blur. Block blur just takes all the pixels, all the neighboring pixels, and multiplies them by 1, and then you divide by 25. This is exactly the same as just taking an average of all the neighboring pixels. So the pixels are recalculated, and each pixel has got the new pixel is the average value of all the neighboring pixels, and that's repeated for each pixel. Implementing the divisor is quite simple. Here we have a divisor input. Then we've got sharpen. For sharpen, you take the pixel itself and multiply it by 9 and subtract the value for each neighboring. Now let's have a look at the next matrix. This is a sharpen filter. It sharpens an image. What it does, it takes the pixel itself and it multiplies that by 9 and it subtracts each of the neighboring pixels. This results in a much sharper image than before. I'm going to click on it and deactivate the filter so we can compare and examine the effect. As the next example, we've got edge detection. Edge detection is similar to sharpen, but by dividing by 0,2 we actually accentuate the edges, and by adding 1 we make sure that the background is lighter, much lighter. In order to add 1, it's relatively simple. We just set the bias to 1. Then we've got emboss. Emboss just gives a sort of a 3D effect. It takes the top left pixel, multiply by -2, add it to the pixel itself, and add it to twice the bottom right picture, so that the whole picture is shifted a bit to the right and down, and then overlaid on top of the original picture. Next, let's look at the remaining inputs. We've got target. Target is the x and y coordinate of the target point in the Convolve matrix. The convolution is applied to the pixels around this point. By default, it's set to 0, 0, and that means the center point. So the center value is the original pixel which is being recalculated. If I set target to 1,1, then it would be this one which gets recalculated, and all the neighboring points would be these. These would be the neighboring points. We've already talked about divisor and bias, and when it comes to edge mode, that's actually defining how to deal with pixels which are on the edge. If you recall, when recalculating pixel P11, what am I supposed to do with these values M11, M12, M13? You can specify how to deal with those values using the edge mode, but I always leave it on duplicate. So that was quite an abstract lesson. It's not so easy to understand if you don't understand it fully. Don't worry, the most important thing is that you know how to implement it and you know some commonly used convolution matrices. If you want to know more, go to the Wikipedia site of kernel and image processing, and here we have some examples of different convolution matrices and what they do. And you can also click on extra links. That's it for now. Have a nice day. Bye bye.